So we are going to talk about complex circuits. And a complex circuit is just going to be a resistor, something that's more than just purely a series or a parallel circuit. So complex just means it could be a little bit of series, a little bit of parallel mixed together. It's not just purely one or the other. Before we do that, I want to remind you, remember that if you ever see the word equivalent resistance or total resistance, that just means that it's looking at what is the resistance of all these resistors if the from the battery's viewpoint, from the voltage viewpoint. So if you have all these resistors, you can also just, I'll skip ahead. So if I go to a resistor that looks like that, I might have a bunch of crazy resistors going on, but I want to know what's the actual resistance that the battery feels. So what I'm going to do is I'm going to turn that into one resistor, a simple circuit, and say, what is the equivalent resistance of this? Okay, so before we get started with that craziness, let's talk about just the idea of a little shortcut for parallel circuits. If you see resistors that are in parallel, and if you see them and they have the same value, so let's say in this case we have 6 ohms all in parallel. What I can do is anything that's the same value, I can divide by the number there is. So if I have a 6 ohm resistor and I have 3 of them, I can divide 6 ohms by 3. And that means my equivalent resistance, or R total, is going to be only equal to 6 divided by 3, or 2 ohms. So all those extra resistors actually create a smaller resistance in parallel. All right. So if I want to redraw this, this would just be a 2 ohm resistor, and that would replace it. Now, it doesn't mean that that's really what the circuit's going on, but from the battery's viewpoint, that's what it feels. It feels 2 ohms that's going to cause so much current to run through it. All right, well, what if you have something that's not all the same, but some are the same? Well, you can do that as well. You can take the two 12 ohm resistors right here, and it actually doesn't matter what the order is. You can rearrange parallel. It doesn't really matter which order it's in, okay, as long as they're all the same. It could be 6, 12, 12. It could be 12, 6, 12. Doesn't really matter. But if I have these two 12 ohm resistors, I can first just take care of that and say, all right, I have two 12s in parallel, so 12 ohms divided by 2, and I get 6 ohms as my new resistance of those two. And then I can replace, so that's the same thing as having a new resistor. If I want to get rid of all that, I could just say that there's a new resistor over here that's 6 ohms. So now I have 6 and 6 in parallel. So 6 and 6 in parallel, 6 ohms divided by 2 of them. The equivalent resistance of this circuit would be 3. Okay, so that could be redrawn as one 3 ohm resistor that the battery's hooked up to. So anyways, that's the shortcut. If you have resistors, they have to be the same value. But if you have two resistors of the same value, you can divide it by 2, and that's the equivalent, and so on and so forth. Okay. All right, now let's talk about this. This is a complex circuit. And it's not, the 5 and the 8 are not purely in series. I can't do anything with that 5 and 8 yet. I can't do it with 5 and the 8, the other one too, but the 8 and the 8 are purely in parallel. So I can take care of a parallel circuit first. So what I want to do is I want to take these two 8 ohm resistors and simplify it into something that looks like that, something that has just one resistance to it. Okay, so I go back and I say, all right, I see an 8 and an 8. Well, 8 divided by 2 of them is going to give me, divided by 2 of them is going to give me a 4 ohm resistor. So I have 8 divided by 2, that gives me a 4 ohm resistor. Okay, so here I really have a 4 ohm resistor. Now it's in series, and this is purely in series. 5 and 4 are in series. So I can say 5 plus 4, and I have 9 ohms is the equivalent resistance of those two. So I could draw that into this, and now I have the 9 ohms that I just figured out. Okay, so we went step by step. We went from 2 in parallel that I could take care of, then to 2 in series, and then I moved along to the getting one resistor. Now what we can do with this, we have a 63 volt voltage supply and 9 ohms of resistance. Now let's figure out what the current is going through that battery. Because I have just one resistor, I can use my Ohm's law, V equals IR. All right. V is going to be, so I can do a little algebra, V divided by R. V is 63. R is 9. Okay, so I have 7 amps is going to be running through the resistor, which means there's 7 amps that's leaving this battery. So now I can work my way back. If I have those 7 amps that I know that's leaving the battery, it's still the same with this picture. So I see I have 7 amps that leave this battery. And that means it follows along and there's no splitting up going on yet. So I have 7 amps is going to go through the 5. Okay. Then when it comes down here, here's where you're going to get a split. Some's going to go one way, some's going to go the other way. Because it's the equal resistance, because they're the same values, it's going to split up equally too. So I know that this will be 3.5 amps going through one side, and I'll have 3.5 amps going through the other side. Okay, so then they split up. When they meet back again down below, it'll be 7 amps once again. All right, so that's a way you go through something and you can figure out, well, what's the current going through the whole circuit, and then I can split it up. And you could work your way through and you could figure out, well, what's the voltage then across this, or whatever else you need from that. Okay? All right. One last thing, just to remind you, voltage drops. So when I say the word voltage drop, like going back to here, right? The voltage going across that resistor is going to be 7 times 5. Okay, that would be a voltage drop, and it just means the voltage that went across that resistor. Okay, that is it for my lecture. Thanks for watching.